Hello everybody. So in today's lesson we're going to continue with implicit differentiation, and I think it's notes number 28. And what we're doing today is evaluating the derivative at a particular point, which is something that I kind of mentioned we would be doing in our last lesson, and I gave you a little bit of a heads up about what you want to do for that. So remember, implicit differentiation is the process we use to differentiate some sort of relation which does not have y isolated. So if you look at number 1, this is a great example of some kind of equation that does not have y isolated. And we use the chain rule to do this. So every time we're differentiating something that's not with an x variable, like this term here that has a y here and here, we're going to need to multiply by the derivative of the inside. And the derivative of the inside means the derivative of y, and that's going to be dy dx, which we also can call y prime. It's easier to write y prime. Okay, so let's go ahead and start with implicit differentiation of this equation. And it looks like for the first term we're going to need to use the product rule. So for this one we have the first times the derivative of the second, and the derivative of y squared would be 2y times y prime. Remember, y is not our variable, x is our variable. And continuing with the product rule, plus the second times the derivative of the first. And then moving on to the next part, we're going to use the product rule on that as well. So the first times the derivative of the second, plus the second times the derivative of the first. And then the derivative of negative 10x is just going to be negative 10. And the derivative of y is going to be y prime. And the derivative of 5 is going to be 0. Okay, now, if all we were doing was finding dy dx, at this point we would try to isolate y prime. However, we are finding dy dx at the point 2, 1. So we're going to put 2 in for x and 1 in for y, and now is the best time to do that. So you don't have to go through all the algebraic simplification. You can first put the numbers in there. So we have 2 cubed times 2 times 1 times y prime plus 1 squared. Of course, you don't have to write the times 1, and you don't have to write the 1 squared. You can leave that out. I'm just doing it to be thorough for you to understand. 1 squared times 3 times 2 squared plus 2 to the 4th times 3 times 1 squared times y prime plus 1 cubed times 4 times 2 cubed minus 10 plus y prime equals 0. Okay, let's keep going. 2 cubed times 2 times 1, that would be 16. So 16y prime plus 1 squared times 3 times 2 squared, that would be 12, plus 2 to the 4th times 3 times 1 squared. Let's see, that's 16 times 3, that's going to be 48, so 48y prime. 1 cubed times 4 times 2 cubed, that would be 32. Minus 10 plus y prime equals 0. Okay, let's combine our y prime terms. We have 16 and 48, which is 64, and 1, which is 65. So 65y prime. And then I'm going to add 10 to the other side, subtract 32 from the other side, and subtract 12 from the other side. So let's see what would that be. So 10 minus 42, that's negative 30. Or 10 minus 44, that's negative 32, right? Negative 34. I should not be trying to do this in my head. Negative 34. Yes? Yes. Okay. And then divide both sides by 65. So we have negative 34 65ths. It would feel much better if it was an answer like 2 or something. Whenever you get these not so user-friendly fractions, it's a little bit disconcerting, like you think maybe you've made a mistake somewhere. I'm just going to pause and double check my work. All right, well, I'm not seeing anything wrong, so let's keep going. Find the equation of the tangent line at the point pi over 4, pi over 4. Okay, so we get to work some trigonometry into this, and the first step is going to be to find the derivative at that point. So we need to take this equation and implicitly differentiate it. So let's see, the derivative of sine is cosine, so we have cosine of x minus y. And then we need to multiply by the derivative of the inside, and the derivative of x minus y would be 1 minus y prime. And then on the other side we have a product, and the first is x, and then the derivative of the second, so the derivative of cosine is negative sine, times the derivative of the inside, so the derivative of y plus pi over 4 would be y prime plus 0. So that's the first times the derivative of the second, plus the second times the derivative of the first, and the derivative of x is just 1. Okay, so now let's put our numbers pi over 4 in for x and y and simplify. So cosine of pi over 4 minus pi over 4 times 1 minus y prime equals pi over 4 times the opposite of the sine of pi over 4 plus pi over 4 times y prime plus the cosine of pi over 4 plus pi over 4. Now I'm just taking this slowly. You might simplify a little bit more quickly than I am. So this is going to be the cosine of 0 times 1 minus y prime equals pi times the opposite of the sine of pi over 4, or excuse me, can't even say excuse me. Pi over 2 is pi over 4 plus pi over 4 times y prime plus the cosine of pi over 2. Okay, so now we find our exact values. Looks like all of these exact values are quadrantal, so you can use your unit circle. This point here, 0, has coordinates 1, 0, so cosine is 1, sine is 0. This point here, pi over 2, has coordinates 0, 1, so cosine is 0, sine is 1. So the cosine of 0 is 1. The sine of pi over 2 is 1, so this is going to be negative 1. And the cosine of pi over 2 is 0. So what we have is 1 minus y prime equals negative pi over 4 y prime. Okay, let's gather our y primes together on one side. So I'm going to add y prime to both sides. So we have y prime minus pi over 4 y prime. So this is not going to be the nicest looking number you've ever seen. Okay, let's factor y prime out of both terms. So we have 1 equals y prime times 1 minus pi over 4. Now, how can I rewrite 1 minus pi over 4? Let's see, I can think of it as 4/4 minus pi over 4. So that would be 4 minus pi over 4. Okay, so we have 1 equals y prime times 4 minus pi over 4. And the reason I did that is because now to isolate y prime, we have to divide by that fraction, which is the same as multiplying by its reciprocal. So that means we're going to get 4 over 4 minus pi equals y prime. Now that is the slope of the tangent line. Remember, our goal is to find the equation of the tangent line. And the point was pi over 4, pi over 4. So now we have the slope. Let's use the slope and the point. So we have y minus pi over 4 equals the slope times x minus pi over 4. Okay, this is not going to be pretty. Let's see here. We could distribute. So we have 4 over 4 minus pi times x minus, okay, now we're about to multiply this by this, and notice there's a 4 on the top and a 4 on the bottom, so we'll cancel those, leaving us with pi over 4 minus pi. And then we need to add the pi over 4 to both sides. So if y equals 4 over 4 minus pi times x minus pi over 4 minus pi plus pi over 4. Is it necessary for us to combine these two fractions together? Nope. I think this problem is good enough. If you wanted to combine those two fractions together, though, if you don't care, just fast forward through this part, but if you wanted to, you would have to get a common denominator. So you'd have to multiply the second fraction by 4 minus pi over 4 minus pi, and multiply the first fraction by 4 over 4. So we would have negative 4 pi plus, now I'm going to distribute, 4 pi minus pi squared over 4 times 4 minus pi. Negative 4 pi and positive 4 pi cancel, so we would have negative pi squared over 4 times 4 minus pi. And even though it doesn't matter to me if you combine them or leave them separate, you know there are times when you look up your answer and the answer looks different, and it may just be because one person simplified and the other person didn't, and you need to know whether or not you have an equivalent answer. Okay, let's keep going. We have one more problem. Show that no point of the graph here has a horizontal tangent line. So here's the concept. A horizontal tangent line has what slope? You're right, the slope is 0. So that means that the derivative would be 0. So what we have to do is show that this equation doesn't give us a y prime value of 0. So let's go ahead and implicitly differentiate. So the derivative of the first term is 2x, and then I'm going to call the negative 3 a constant out in front, and then in parentheses I'm going to put the derivative of the product xy. So the first x times the derivative of the second y prime plus the second y times the derivative of the first one. And then the derivative of y squared would be 2y y prime, and the derivative of 1 would be 0. Okay, we are going to need to isolate y prime now, and we don't have a point to plug in. So I need to get rid of the parentheses. So we have 2x minus 3x y prime minus 3y plus 2y y prime equals 0. Let's keep the y prime terms on the left, and then let's get the other terms over to the right. Let's factor out the y prime. And as a matter of fact, we can take this term right here and we can write it as 2y minus 3x. It just looks a little bit better that way. So I'm going to divide both sides by that and write it as 2y minus 3x. Wow, that numerator and that denominator, oops, look very much alike, but they are not like terms, are they? They're not the same factor, and there's no reducing we can do there. So we need to show that there's no way that this can be 0. Well, let's suppose it is 0. If 3y minus 2x over 2y minus 3x is 0, then the numerator would have to be 0. So it would be 3y minus 2x equals 0. And that would mean that 3y was equal to 2x, and that would mean that y was equal to 2/3 x. So what we're going to do is take 2/3 x, put it into the original equation for y, and show that it doesn't work. So, giving myself a little bit more space here, let's see. We have x squared minus 3x times 2/3 x plus 2/3 x squared equals 1. Okay, let's scroll down there, give ourselves a lot of room. We want to show that this has no solutions. Okay, let's simplify. So we have x squared minus, when we multiply this, we get 2x squared, plus, when we square this, we get 4/9 x squared. So all these terms are x squared. Let's combine them. 1 minus 2 is negative 1, and negative 1 is the same as negative 9/9, and then we add 4/9. So we have negative 5/9 x squared equals 1. And then that means x squared would be negative 9/5 if we multiply both sides by negative 9/5 to get x squared by itself. Well, for a number to be squared and be negative, it would have to be a non-real number, an imaginary number. So x is not real, but in calculus, we're just working with real numbers, at least at this point of the game. So we did not find any real numbers that give us a slope of 0. So yay, that's done. No points give slope equal to 0. Okay, here's your assignment. There are 4 problems I'd like you to do. Thanks, everybody.